object and you have another object. I'll just crash course through the other stuff you need to know as well. So let's say this one is plus 5 coulombs or nanocoulombs or picocoulombs, or remember in this topic you need to know nano, giga, gaga, all those things. Okay, and this one is minus 18. Okay, so it could be coulombs, it could be nanocoulombs, it could be anything. When they touch, what do? They share the charge. So it's going to be plus 5 minus 18. But then when they split up, they're going to divide that charge in 2. So you're going to divide it by 2. So plus 5 minus 18 gives me minus. So that's going to be minus 13 over 2, which means this one will end up being 6.5 coulombs and this one will end up being 6.5 coulombs. So that's important. You need to be able to do that. But you need to make sure you show the charges here. Okay, now the next question that they can ask is how many electrons are transferred? Okay, what a lot of you did in the test is you used this final charge to work that out. That is wrong because that is the excess of electrons that it has now. And this is the excess of electrons that this one has now, not what was transferred. When you look at the difference between there and the difference between there and there, it needs to be the same. So that is the change in charge. So the change in charge here is what? Say again? It's from positive 5 to negative 6.5. So yes, I agree with the 11,5. And if you do it on this side, if it's not the same answer, you have done something wrong. So that's a way to check that your answer is right. So this one, the change in charges should also be 11,5. That means that the one gave off 5 or 11,5 and the other one gained. Now, this is the next question they always ask. Which one lost, which one gained? The negative one will give electrons to the positive one. So it's always from the more negative one to the more positive one. So if this is A and this is B, it's going to be from A to B. The question can be asked in all kinds of different ways. But now if we ask you how many electrons, so the number of electrons transferred, you don't get this equation on your information sheet. So the number of electrons transferred is then always going to be the change in charge, not the final charge, over the charge of one electron. So you get it on your information sheet, it's QE. We give you that value. So the change in charge here it's a number of electrons. It can't be negative. So it's just going to be the 6,5 divided by 1,6 times 10 to the minus 19. And make sure you can do this. Oh, can you see what I just did? What half of you did in the last exam? Okay, it's not 6.5. Well done, you're awake. So it's the change in charge, which is 11,5 over the charge on one electron, which is 1.6 times 10 to the minus 19. And you do that on your calculator. Are you going to get a huge value or a small value? 7,1? 8. 10 to the 19.
Yes, ma'am. What? Yes, ma'am. 7.
Yes, ma'am, that's right.
1,
Oh no, if you running it was at 7,19. Running.
7. Oh,
Okay. Remember, we round off to 2 decimal places, but only in our final answer. Okay, so that is the number of electrons transferred. So that's the first type of question they can ask you. Then for the ratios. For the ratios, they normally give you a first force. So they will say between object A and object B, there is already a force. There's a force F. Will this force be attraction or repulsion? How do you know?
No, we don't know.
You don't know. So if this one is positive and this one is negative, what would it be? Attraction. But if I say, what is the force that acts on A, what are you going to say?
It's equal to the one that acts on B.
It's equal to the force that acts on B, and it's going to act to the right. Remember, a direction is not attraction or repulsion. If you're adding a direction, it must be left, right, towards B, towards A, towards the top of the page, towards the left of the page. You have a page. You can refer to that page if you have to. But let's say this force is 20 Newton. Oh, no, wait, let's not say that. So let's say A has a charge of 200 coulombs and B has a charge of 150 coulombs. Which one will experience the greatest force?
Force.
Which one will experience the greatest force? Guys, you just said it earlier. Now you said it to me. Now yeah, the force would be equal. So not B. Remember, the force between A and B is K, Q1, Q2. The force depends on both charges. There's always a question like that that tries to trap you. The force is the same. Q1, Q2 over R squared. Right, so please look out for that. Fields are different because if you're looking at the fields, which one will experience the greatest field? A will make the biggest field because it's the biggest charge. So A will create the biggest field. But which one is experiencing that field? B. So B will experience the greatest field, but A will create the greatest field. Okay, but you don't have to worry about that for Saturday. We'll do it in detail before you do your matric paper. Okay, so just remember F of A on B is equal to F of B on A. Same force, just in the opposite direction. Please remember that. Okay, now for the ratios, they can say to you, the force was F. Now they're asking you, what would the new force be when the charges, we can't do that, but it's not, let's say we didn't have the values, multiple choice question. Let's say we didn't have the values. The force when the charges are tripled
Oh, yeah, this one.
and the distance between them. Okay?
Too much each charge, man.
Yeah. The charges, okay, my wording should be better. When both charges are tripled and the distance between them is halved. Okay, that's a common type of question. So now, what you're going to do is your first job is find the right equation on your information sheet. We give you all the equations that you need. You're going to find an equation for F. So you're going to say, okay, I know that in situation number one, F was equal to K, Q1, Q2, and it doesn't matter if you use small or big letters, over R squared. But that was before they were tripled. So now we want to know what is the new force going to be. So all you're going to do is you're going to write the equation again. This is really the easiest way to do ratios. And if you can do it for fields, you can do it for all the other sections when that comes at you. Okay, so you're going to write the equation again. Remember, R lives on its own. The 2 is whatever R is squared. So now you're going to ask yourself, is K still K?
Yes.
Yes, it's a constant. Is Q1 still Q1? No, what have I added?
It's triple.
I added a 3, it's tripled. But because there's an equal sign, whatever's on the left-hand side must be equal to whatever's on the right-hand side. So I need to also put a 3 on top of the line here. Is Q2 still Q2? It's 3 times Q2, so we need to put another 3 on top of the line here. Is R still R? No, it's now a half R. So what did I add here? I added a half and in is a squared bracket. So whatever, because it's an equal sign, whatever you do on the left, you must do on the right. This is literally the easiest way to do this, guys. So now all you have to do, if you're unsure about the algebra here, you can literally type it in your calculator and it's going to give you the value. If you go 3 times 2 over, put brackets, put 1 over 2 as a fraction and put 2, it's going to give you the answer. But you should get 24. What do you get? 36. Sorry. No, 3 times 3 is 9 times 4, yeah, it's 36. Is it 36? Yeah, sorry, my maths was bad there. See, I should have used my calculator. So, because you end up with a 9 over 1 over 4, so that becomes 9 times 4. But you don't even have to do that. Remember, you don't have time in a physics paper. Stick this in your calculator, and it gives you 36F, and that's your answer. Does that make sense? It's really the easiest way to do ratio questions.
F new equals 36 times.
Oh, so,
Penyo?
Ma'am, we're allowed to use the constants at the back end.
You're not allowed the back of your calculator.
Ma'am,
But why would you want to?
let's say like we just know.
No, you have to use what's on your information sheet.
so,
Anything else for fields?
my problem was I was doing this right, but I didn't write it.
You didn't write?
I didn't write it like with the what is this? The divide. Like, I didn't put it specifically. I tried to.
Your equal sign wasn't an equal sign.
So now that's all you need to know for electrostatics. How to
Yeah, then in your test though, there was a skills question where they said, I'm just going to do the gist of it. I realized I said the word wrong the other day. Okay, so they said plot a graph of the force versus 1 over r squared. And they told you that it's the relationship between two identical charges. So you knew the charges were identical. So you had your graph. Please remember, guys, when you plot your values, use crosses and make them nice and small and neat. The point must be where they cross. If it's more than half a block out, you don't get the plotting mark. If you do blobs, you do not get the plotting mark. Then you're going to do your line of best fit. If 0 makes sense, draw it through 0. Can there be a force if there's no distance? No. Okay. So 0 makes logical sense. Then you can draw it through 0. You're not going to do the first and the last point. Some people do that. It's wrong. Because now we've got 2 points above and nothing below. So even if it touches none of your points, that's fine. As long as they are evenly spread out. If I do that, I've got 2 at the top, 3 at the bottom, but the bottom ones are closer than the top ones. So I would say that's a nice line of best fit. Then the question said you need to calculate the gradient. Ignore those points. I was at a workshop again this weekend that was done by the lady that has been marking the metric graph for the last, I cannot even remember how long, probably 12 years. She's been marking the graph. And I'll actually share the PowerPoint with you guys that she gave. So people fighting with me all the time about this. But she even said it there. Do not use points from your table. You will get marked down. And I've been saying it since I arrived here. Please do not. Go and find nice points. Go and look for points that are on the dark lines because it makes your maths easier. Then, if I need a magnifying glass to see how you marked them, I'm not going to give you the mark. She clearly said, use a line towards your x and your y axis, and or if you don't do that, go and use a triangle. So go and use a triangle. Um, show this there, that triangle. That clearly shows your points. Then, if you want to mark them, some of you just literally do a little circle around them, and we need magnifying glasses to see them. It must be clearly marked. It even says as an instruction, clearly mark the points. So, one of these methods you must do. Then you label it. This is going to be x1, x2, and this is going to be y1, y2. If you've done that, there's no doubt. You make it easy for me to give, I'll probably mark your graph. You make it easy for me to give you the marks, and I want to do that. Okay, so then you're going to work out your gradient. You're going to say gradient equals, write the equation because it's worth a mark, is equal to change in y over change in x. You don't have to do the y2 minus y1. You can. It's the same mark. And in this one, in the one in your test, the answer was 0.48. And then if it says add a unit, don't get nervous. It was y over x. So you literally just going to put the unit that's on your y. What unit is force measured in? Newtons. And what unit is 1 over r measured in? Meters underneath the line.
Meters squared.
So it's going to be meters to the minus 2 because it's underneath the line. So your unit for this will be force over meters to the minus 2. That will give you the mark. If you want to, you can go and say F and take it to the top of the line, meters squared. But you don't even have to. If it just says give the unit for your gradient, that's the unit for my gradient. Don't worry about it.
It's not n.
Hmm?
N over.
Oh, yes, sorry. Not F, definitely not. Newtons over meters to the minus 2 or newtons times by meters.
You can leave it like that at the first.
Yeah. That's right. Then there's the analysis question. So then the question says, use Coulomb's law equation to calculate the magnitude of each charge. Give the answer in microcoulombs. Now, normally it says use your graph and your gradient. So now if you go and do this, you're going to always connect it to an equation. So they said use Coulomb's law. So F equals K, Q1, Q2 over R squared. Now you go and tell yourself, what did I plot on the y-axis? Because remember you have the gradient is y over x. What did I plot on the y-axis? What did I plot on the x-axis? What did I plot on y? F. What did I plot on the x-axis? 1 over r. So this gives me f times by r, right? Oh, squared, sorry. Got the squares, don't forget the square. Can you see that if you take this to this side of the equation, it gives us this as a leftover? Can you all see that?
Yes, sir.
This is equal to K, Q1, Q2. And we have our gradient already. We know that that is equal to 0.48. So the analysis question is the one that gets you guys down. So now you know the gradient that I calculated was 0.48. I know that that is equal to the change in y over the change in x, which is equal to f times by r squared, which is equal, I'm just writing it again for space, to k q1 q2. The question asked to calculate the value of q. Originally, they told you that the q's were the same. So you can say that that's the same as k q squared is equal to 0.48. Do I know what k is?
Yes, sir.
Yes. I know that k is equal to 6,7 times 10 to the minus 11, I think.
Not 9 times 10
Oh,
is
9 times 10
I've got G. Sorry, that's G.
9.
9.
The 3 is 3.
9 times 10 to the 9.
It's 9.
And Q is then my only unknown, and this becomes your calculator's job. And you must make sure you can use your calculators nice and this. Can you see how what you
I think my calculator should.
That's it.
Unlucky James.
Let me see.
Unlucky James.
Calculator says it's 0. Oh.
But you also have to put it
Remember
in the
to
square root,
square
don't
Am
you?
I getting 7?
But this will only work if the times are the same.
Yeah.
You also have to put it under by square root, don't you?
7.3 times 3.
7.3.
Did you not get that?
I got 7,000.
I can't
don't know why
see
I got
that.
7,000.
Tell me.
You have to
No.
7.3 0
Yeah.
You said 2
Two.
tomorrow.
times by 10 to the power of -6.
So we're going to Q. Okay.
Hold on. I'll do it now.
Hold on. Okay. This is what I was.
Okay?
Let me-
Happy?
Wait.
Is that you?
Okay.
Wait.